All right, so on this worksheet, you're solving an exponential equation, and these problems are not that difficult because in these problems, when solving these exponential equations, you're able to get the bases to be alike. And so when doing this problem, these four problems, there are four problems here. When you do these four problems, you want to solve this by using like bases. Now, in another section, there are times when you cannot get the bases to be identical. So in that case, you're going to have to use logarithms. But in this, remember, always follow the directions. So the direction says solve each exponential equation by using like bases. Now remember, an exponential equation is an equation where the variable appears in the exponent. So notice the variables in the exponent in each of those cases. All right, so let's look at number one. So number one, we have 4 to the 3x minus 5 equals 16. And I want you to notice that the base here is 4 and the base here is 16. So they're not alike. But we all know that it's pretty easy to get those two bases to be the same. Because we all know that 16, I can write 16, I can write as 4 squared, right? 16 is 4 squared. So this becomes 4 to the 3x minus 5 equals 4 to the second power. And we talked about in the lessons, we talked about one-to-one correspondence. So for example, if 2 to the x power equals 2 to the fifth power, right? So if I want to solve this exponential equation and I know that 2 to the x equals 2 to the fifth, I want to find out what that x is. Well, we all know based on what we see, you can even look at this right here, based on what we see, that in order for the left-hand side to equal the right-hand side, the exponents have to equal. And notice that you have this one-to-one correspondence here in terms of the bases being identical. So you have 2 to the x equals 2 to the fifth. So as long as the bases are the same, then that means that the exponents have to be equal to each other. And that's how you solve for x. You just set the exponents equal to each other. So in our case here, we now have the bases be the same, so therefore the exponents have to be equal to each other. So if I'm going to solve this exponential equation right here, then I can use the fact that this exponential equation is equivalent to that equation. And so the bases are the same, so therefore the exponents have to be equal to each other. And so there's your equation. So now all I have to do to solve for x is solve this linear equation. So we're going to add 5 to both sides. So I get 3x equals 7. So dividing both sides by 3, I get x to be 7/3. And so there's your answer, 7/3. Okay, let's do this one. Over here, I have 8 to the 9x plus 2 equals 64. Well, think about this. Think about that 64, right? So 64 in terms of 8, I know I can do easily because I know that 8 squared equals 64, right? So this becomes 8 to the 9x plus 2 equals 8 squared because 8 times 8 is 64. So just like we just did with this one, since the bases are the same, then that means that the exponents must be equal to each other. So that means that 9x plus 2 must equal 2. And then solving this linear equation, I'm going to get, if I subtract 2 from both sides, I'm going to get 9x equals 0. Dividing both sides by 9, I get x to be, and then 0 divided by 9 is 0. So you need to make sure you say that 0. Don't say 0 divided by 9. You're expected to know that 0 divided by 9 is 0. And so there's your solution, 0. All right. And then, and you could easily check these. For example, watch. Let's go back and check these visually. So 7/3. So 3 times 7/3. So let me write this on here. Okay, watch. So 4 to the 3x minus 5 equals 16. So we're checking that x equals 7/3 is a solution. All right, so I get 4 to the 3 times x is 7/3, right? And then whatever that is, I'm going to subtract 5. Well, 3 times 7/3 is that 7? Yeah, 7. So 3 times 7/3 is 7. So it becomes 4 to the 7 minus 5. 7 subtract 5 is 2, so it becomes 4 squared, and we know that 4 squared equals 16, which is what this was. So it's pretty easy to check these. Same thing with 0, right? So with 0, notice right here, you have 8 to the 9x plus 2 equals 64. Well, if x is 0, then 9 times 0 is 0. So this becomes 8 to the 0 plus 2. 0 plus 2 is 2. And 8 squared is 64, which is what this is. All right? Okay, let's look at number 3. In number 3, we have this situation. Now, notice this is written as a fraction. All right, so you got to remember a couple of things from previous courses about exponents. All right, and one of the things you got to remember from previous courses about exponents is this. We can always write like 8 to the negative second power. You always want to rewrite a negative exponent. In this case, a negative exponent is a positive exponent. So I can write that as 1 over 8 squared. So that's what 8 to the negative second means. 1 over 8 squared. All right. And I can also go backwards. So if I have 1 over, let's say, 3 to the 4th power, and I take this 3 to the 4th and I put 3 to the 4th in the numerator, just remember when you go from, when you write an expression, whether it's algebraic or numeric, that's in the denominator, and you rewrite it and you put it in the numerator, or backwards, numerator to denominator, the sign of the exponent changes. So 3 to the 4th means the same thing as saying 1, see the 1 here's the numerator, 1 times, and all we're doing is putting this in the numerator, 1 times 3 to the negative 4. And so 1 times 3 to the negative 4 is 3 to the negative 4. So what that means is that 1 over 3 to the 4th is 3 to the negative 4th. Those are equivalent. All right, now, knowing that, let's talk about this right here. Okay, so I have 4 to the x minus 5. Now, before we start using any of these ideas here where we bring something from the numerator to the denominator or denominator to the numerator, let's think about 64. 64. Is there any way you can write 64 as 4 to a power? Because that's what you see here. The base here is 4. All right, well, use your calculator. Let's see what 4 squared is, right? So 4 raised to the second is 16. 4 raised to the third is 64. There we go. So 64 is 4 to the third. So what you want to do is you want to replace that 64 down here with 4 to the third. So it becomes 1 over 4 cubed. All right, now remember, in order to use the fact that we set the exponents equal to each other, your bases must be the same. Okay, so if the base is the same, then the exponents are equal. Be a little bit careful here. The bases are not the same because this is a 4 here, whereas this is not a 4. This is not written as 4 to a power. This is written as 1 divided by 4 to a power. So what you want to now use is the fact that 1 divided by 4 cubed means the same thing as 4 to the negative third. That's what you want to use. And so therefore we have 4 to the x minus 5 equals 4 to the negative third. And now we have the bases identical. So if the bases are equal, then the exponents have to be equal to each other. And so then you get x minus 5 equals a negative 3. Adding 5 to both sides, I get x equal negative 3 plus 5 is 2. And there's your solution. X is 2. And you can check this. So let's just check it real quick. So we're going to check x equal 2, right? So go back to the original. So 4 to the x minus 5. And you want to see that's equal to 1 over 64. Well, if x is 2, this becomes 4 to the 2 minus 5. Well, 2 subtract 5 is a negative 3. And we know that 4 raised to the negative third power means the same thing as 1 over 4 cubed. And 4 cubed is 64. And so those are equal. All right, number 4, let's take number 4. So I have this base here is 9, this base here is 27. So let's think about 9 and 27. All right, so what some students make a mistake is they say 27 is 9 cubed, and it's not, right? This right here does not mean 9 times 3. This right here means 9 times 9 times 9. So right away, you know that 27 is not 9 cubed. That's something I see quite often. So you have to think about what you're writing. All right, so that's not a true statement. So then we got to think about 9 and 27. Is there a way I can write 9 and 27 as both of those having the same base? All right, so let's think about 9. I know I can write 9 as 3 to the second power, right? Can I write 27 as 3 to a power? Well, let's think about that. 3 to what power is 27 if possible? And it is possible because 3 raised to the third power is 27. So that's 3 to the third. So I know I can write 9 as 3 squared, and I know I can write 27 as 3 squared, so hence we have the same bases. So now we're going to go back and we're going to change 9 and 27 to 3 to the second and 3 to the third, respectively. So I get, now make sure you put that in parentheses, so I get 3 squared, remember that's your 9, so you're replacing 9 with 3 squared, but it's being raised to the 2x minus 1 power, equal, and then 27 is 3 cubed, and it is also being raised, in this case, to 3x plus 4 power. And one of the things you got to remember from a previous course is this. Whenever, let's say we had 2 cubed raised to the 4th power. So to get rid of the parentheses, remember whenever you have a power to a power, using a power rule here, whenever you have a power to a power, you multiply those exponents. So 3 times 4 is 12. So this is 2 to the 12th power. And it kind of makes sense, right? Because 2 cubed raised to the 4th means 2 cubed times itself 4 times. And then when you multiply like bases, you add exponents. 3 plus 3 plus 3 plus 3 is 12. So you get 2 to the 12th. But the thing is here, what you want to do is when you have when you have an exponent raised to another exponent, you're going to use a power rule. You have to multiply these exponents. So now what you want to do is rewrite the left-hand side so it looks like this. 3 to the 2 times 2x minus 1. That's what this means. This right here, multiplying those exponents, all of this is being multiplied by 2. So make sure you put that in parentheses like this. Same thing over here. All of this 3x plus 4, both terms here, is being multiplied by this exponent 3. So you're going to say 3 raised to the 3 times, in parentheses, 3x plus 4. And so now, remember you're trying to solve for x. X is in your exponent. So now we know that since the bases are now the same, those exponents have to equal to each other. So what that means is that the exponent here, which is 2 times 2x minus 1, must equal the exponent here, which is 3 times 3x plus 4. And so now all I have to do is solve this linear equation. So let's go ahead and use the distributive property. So 2 times 2x is 4x. 2 times negative 1 is a negative 2, equal 3 times 3x is 9x, and then 3 times 4 is 12. Subtracting 4x from both sides, I get negative 2 equals 9x minus 4x is 5x plus 12. I'm going to write that here. So negative 2 equals 5x plus 12. All right, and then subtracting 12 from both sides, a negative 2 and a negative 12 is a negative 14 equals, this is 0, 5x. And dividing both sides by 5, I get x to be negative 14 fifths. All right, and then reduce if you can, but leave it as a fraction or a mixed number, but don't write as a decimal because sometimes those decimals don't terminate. And so we get x equal negative 14 fifths. And there's your answer. All right, and so that's it. So that's how you solve an exponential equation by getting the bases to be alike. But these exponential equations, if it says use like bases, then you will be able to manipulate these to where you can get the bases to be identical. Okay? All right, so that's it.